Hello there. Alright, this is just a simple program to calculate, to write a program which calculates the roots of a quadratic equation, whether they be real or repeated roots or complex roots. Okay, um, this is just freestyling, so I'll just dive into it, and hopefully this will be beneficial in terms of highlighting the way you tackle some of these problems and how you would go about solving them, and in the thought processes involved. Okay, so this is how I would do it, right? So definitely I know that I need to calculate the roots of a quadratic equation, given for example, y is equal to ax squared plus bx plus c. Using the quadratic formula, I'll have a root sign somewhere there, right? The discriminant is a root sign. What else? The inside the discriminant b squared, right? Because it's b squared minus 4ac. So having a root sign, having square, then I know that I need to use, I don't want to keep on typing like all those math functions, so I will just, all those math operations, so I'll just use the math functions provided to me by C. So I will hash include standard input output, of course, because I'm going to use printf and scanf statements. I'm going to ask the user to enter the values of A, B, and C. Okay, I am going to use the math function, so I need to include the math library. Okay, header files only contain function prototypes, that's all. So this is just us telling the compiler, hey, if you're gonna run this program, be aware these are the guys you're gonna find inside there. Alright, so that it's not surprised or anything like that. Okay, let's start from there now. So int main, and I return 0. I had just write it because I forget it in the end. It usually doesn't have any effect whatsoever. One other thing that you could have done is void main. You could have done that instead of using int main. One and the same thing, and here you wouldn't have to include a return statement. I just used the first one because most people are used to that one. So yeah, okay. Let's see. So we definitely want to take in these numbers, right? So let's make let's declare these variables. We're going to store A, B, and C. But now, mind you, the user may enter something as small as integers or as big as like millions, So to safeguard your program, just use doubles. They are capable of handling all those things, right? So double A, B, C, right? And these are the coefficients of the quadratic equation, or more appropriately, coefficients of the terms in the quadratic equation, right? Okay, so let me for explanation purposes do this. Okay, so we know that y is equal to a times x squared plus b times x plus c. That is the function, right? And oh, by the way, just for fun, let's just make this program also calculate the maximum and minimum of these of these functions, right? Then you have dy dx, which is y prime, in other words, being equal to 2 times a times x plus b when you differentiate that, right? And the roots of the quadratic equation are given by y1 y2 is equal to minus b plus square root, so let me put that in brackets there, all that to the power of half, 0.5. So square root of what? Square root of b squared minus 4 times a times c, all of that divided by 2 times a. Alright, now imagine having to type that out. It's not so nice, eh? And it impedes readability. If someone was to have your code, it would be difficult for them to debug if there was an error somewhere in your code. Okay. And the roots of the second equation, oh my apologies, this should be x1 x2, not y1 y2. Okay, the roots of the equation x1 x2 where y is 0. Alright, and then when trying to find your minimum, then you know that dy dx is 0, your minimum or maximum, the stationary point, right? And then if y prime is 0, then you know that x is simply going to be equal to b minus b, that divided by 2a. Okay, that is what we have. So we are going to need this information later onwards, right? Cool. Let's go back in there. Let's just ask the user first. Let me just write something. This is for Eclipse, because Eclipse is a bug when it comes to input and output stream. So I have to include this statement to buffer the output. Standard output 0. Okay. All right. Let's proceed there, and then printf. Enter the coefficient of x squared. Okay. Printf. But before that, my scanf, and this is a double %lf, and I'm storing that in A. Okay. Now let's ask them to enter the coefficient of x. That will be %lf again, and store that enter the coefficient, no, rather enter the constant term. Or enter the coefficient of x to the power 0. That's still the same thing. And scan f. Okay, now we have done that. But now there's a problem, right? Let's look at our formula right here. Right there. If we divide, we're dividing by 2a, right? If a is 0, you've got a problem now. You've got a huge problem. It's going to give you errors, right? Overflow. So we want the user to always enter the value of a. Okay. So how do we keep on checking for that? Let's use a do while loop. So I want you to do all of this while a is not equal to 0. Oh, sorry, while a is equal to 0. So as long as there's 0 in a, then we should keep on asking the user to enter up until they enter something else other than a. Okay. Alright, now let's proceed. Maybe let's just put a warning at the top there as well. Printf the coefficient of the x squared term cannot be 0. Okay, nicely done. Let me indent my code. Perfect. Alright, now we have the right stuff there. Okay, so we've scanned in a, b, and c. Now what do? We want a function which will calculate the roots, okay, and display them. How do we do that? Let's write a function. Okay, void calculate roots double a double b and double c. So this function doesn't return anything. It'll calculate the roots and display them from within the function itself. And then let's do that. Okay, so there is our prototype there. Now let's write the function down here. Let me separate those. Alright, so we first want to check if the discriminant is positive. So there are three conditions, right? The discriminant is greater than 0, or it's less than 0, or it is equal to 0. That's when you have your three distinctions of the type of roots. If the discriminant is greater than 0, then the roots are real and different. If the discriminant is equal to 0, then the roots are repeated. If the discriminant is less than 0, then the roots are imaginary. Okay, so let's start with the scenario A when the roots are real and distinct. So we will have double disk, right, for the discriminant, and then I will say disk is equal to, I want to raise b to the power of 2 and then minus 4ac, that is the discriminant, right? So it will be power b to the power 2 minus 4 times a times c. Okay, now let's start. If disk is greater than 0, then we want to do something. So let's look at that now. So if the discriminant is greater than 0, then we want to calculate the roots from there, right? So let me just declare at the top there, along with disk x1, x2. Okay, then x1 will be equal to minus b plus square root of the discriminant, and I use the square root function from the math library, all of that divided by 2a. Alright, and x2 will be equal to the same thing, but only that now we're taking the other root, so I'm just going to copy paste that. Okay, that is perfect. Alright, then I can print out the results. Printf first root is percentage, I'm going to print it out to 3 decimal places, and that would be x1. Printf the second root is percentage 3 x2. Alright, maybe let's just add something extra here to say the roots are real and distinct. Okay, alright, we're done there. Now what about the other condition? I didn't terminate there. What about the other condition, right? Else if this is equal to 0, then we need to do something again, and in this case we need to print out that the roots are repeated. In this case, we don't need to waste calculating power because it's all gonna be the same, so you only need one. Should have copied all of that all at once. The roots are real and repeated. Okay, the first root is that. The roots are just that, and that should be enough. And then here we have the else for when it is less than 0. Else, then in this case we need to make it positive at least so that we can calculate. So else disk is equal to -1 times disk, right? So that we can actually calculate the root, because otherwise we'll be calculating the root of a negative number and that will give you errors. And then now we can do what exactly we did here. Nope, not precisely, not exactly. So let's declare other variables here. Just one, let's call it C. Okay, so then this will be C will be equal to the square root of the discriminant. Okay, and then now we can then print out. Not before that, then this becomes divided by 2a. Okay, and x1 as well will be equal to minus b divided by 2a. Alright, now we can print out. Let me just copy all of those statements. Auto intent. The roots are imaginary. Let me just delete that one. And then the first root is %.3 LF plus, because I wanted to display it in a complex form, so I wanted to display something like x plus yi or j, depending on which you prefer, right? For the complex number -1. So this will be that plus that, and then I put my I there at the end, and I copy all of that. Okay, but here this would be first one would be plus, that one would be minus. Okay, and this on this side, this will be x1 and the other one will be c. Same as here, x1 and the other one will be c. Okay, now let's see. Oh, my apologies, c has already been used up here, So this was going to give us errors because C is already one of the parameters, right? So it's already a local variable and I'm already declaring it. So let's choose another name here. Let's call it what we call it, Y, because we don't have Y anyway. And everywhere where I have C, I have to put Y. And there you have it. Okay, I believe this should be enough for the first part. I'll make another video to add on to this one to make sure that we then focus on the second part, which is making the program be able to calculate the minimum and maximum of the functions. This video is already too long, and I know that the concentration span of many of us is quite limited. Or rather, we have better things to do, let me put it that way. Okay, so let's run this and see the output we get. Okay, Eclipse will start this, so I just need to close the project and reopen it again. And it's building, and there. Alright, let's see what happens if I enter 0. Then I have 0, and I have 12, and I have 1. You see, it won't allow me because x is still 0, so I need to enter the proper stuff. So let me put 2, 12, 1. Okay, something went terribly wrong. What could that be? Check. Something very silly, which I'm just remembering now. I didn't call the function in main, so nothing was done here. So let's call the function in main. Calculate rows and assign to it those coefficients that have been entered by the user. So I invoked the call of the function in main, and I call it assign to it the arguments all of type double, and then it will do its thing. Okay, now let's do that. Okay, 1, 12, 1. The roots are really indistinct, and they are those ones. So let me use my calculator to just check if I typed everything correctly. Right. And that is a quadratic equation. So A is 1, B is 12, and C is 1. And the first root is minus 6 plus root of 35, which is minus 0.084. Yes, that is correct. And the second root, minus 11.916. Yes, that is correct. So this works. Okay, I hope this was worthwhile your time, and I hope it helped you understand some of the things and how to approach these problems and how to just in general practice. This is just something which came at the top of my head, and this is how you do programming, at least from my perspective. Otherwise, have a lovely day and enjoy.